consider that you are an IPv6 developer. So consider yourself, right? You are designing this protocol, and Rahul and Anjali are sitting here. They are brainstorming, and somebody has said, remove broadcast. We do not want to have broadcast. Simple, that is okay. If you do not want to have broadcast, let's design a system around this. So whatever we just see, some of the concepts, interesting concept, multicast, layer 2 and layer 3 multicast, believe me, with that, we can eliminate broadcast. Try to understand why we are having broadcast in IP, because we want to get the destination MAC address if we know the IP address, right? So what is happening here? See, I am writing ping here, ping to 2001 colon 20. What will be happening here? We do not have ICMP here, but the next version of ICMP in in IPv6 is ICMP version 6. At which layer it works? It works at layer 3. So what is going to happen if I write ping? If I write ping, this computer is going to generate ICMP, right? Version 6 message, no doubt about it. And which is this message is going to be? Echo request message. What should be the source IP of this message? The source is going to be 2001 colon 10. Destination is going to be 2001 colon 20. What this message is? This message is, sorry, this is not 12, this is 20. This is my IPv6 message. Now the question is same. Now the question is same. We do not have, if we want to place this IPv6 message over this Ethernet interface, I should put source MAC and destination MAC. I know the source MAC is AA, but what should be the destination MAC? Try to consider the fact we can't use the help from ARP, right? Because ARP is not here at all. So what these guys have done, these guys have taken or created some more messages. For example, ICMP had echo request, echo reply, time exceeded message, right? And fragmentation message. So many things are there. So they have developed few more messages. I am not going to talk about it. I'm not going to talk about the name of it because names are confusing. Let's remove that. Let's not talk about name. Now I think you understand the problem, right? If you get the problem, I think then you can build the system, right? So now Anjali and Rahul is saying, interesting problem. ARP is not there at all, but I cannot send this message outside this interface until and unless I have source and MAC address. And how on earth I will get the MAC address if there is no ARP? So Anjali is suggesting some solution. Guys, try to think in your mind how you are going to solve this problem. Amazing problem, right? If I send you into that era, if you understand the problem, then definitely you would have built. So what Anjali is suggesting, right? Anjali is saying, right now, this guy is listening, this guy's IP address is 2001 colon 20. And of course, host A knows where to ping. It knows that it needs to ping at 2001 colon 20, right? Because if you want to start a communication, you should be having the destination address first. And we have that. Anjali is suggesting, see, any IPv6 host will be listening at an IPv6 multicast address, which you can calculate from its IPv6 address. From this IPv6 address, you can calculate an IPv6 multicast address. Interesting. And suppose that multicast address is x colon x. Suppose. Do not worry about it. We will fill x colon x. See, filling, you how to calculate this? It's very easy. Try to understand it first, right? Anjali is saying that this guy who is having this 2001 colon 2064 by default, right? It is written in the protocol that if anybody is having any IPv6 address corresponding to that address, it will be listening at multicast address. If I name it, means if you have solicited node multicast address, if you have said, see, the naming is confusing. Naming brings fear. Let's remove that. Let's try to understand this is x colon x, suppose, right? So now we are going to write the packet. host A wants to ping 2001 colon colon 20, right? First of all, what will be there? First of all, we will be having a message ICMP version 6 echo request for sure, right? And then what we are going to have? We will be having source IP and destination IP. Source IP is going to be our 2001 colon colon 10. And now what should be the destination? See, I know to whom I'm talking to, that computer IP address is 2001 colon colon 20. If that computer calculates his multicast address, host A can also calculate the multicast address the same, that corresponding, I know that whoever is this PC 2001 colon colon 20, right? If it has this IP address, it must be listening on X colon colon X. See what problem we want to solve. And by the way, this is not an echo request message. So what, see, at the end of the day, we need our like messages here, right? So Anjali is saying, see, this packet cannot go until and unless I have the MAC address. I am solving, I want to know the MAC address corresponding to 2001 colon colon 20. So that is why I have created a new ICMP version 6 message in which I have written what is the MAC address, or what is the MAC address corresponding to 2001 colon colon 60, right? This is the letter I have written. This is my ICMP message, ICMP version 6 message. Don't you think that it is the same message like ARP? Absolutely, it is the same message. But at which layer you have created? ICMP version 6 at layer 3, right? So immediately after that, what should be coming? IP header, right? And inside this IP header, the source is going to be this one. But what should be the destination? The destination will be X colon colon X. And I do not need to worry about that. What should be the destination? Because I know in advance that any PC in IPv6, which is having which is having an IP address, must be listening at its multicast address, which is X colon colon X. And if that PC can calculate X colon colon X, I can also calculate X colon colon X. So in advance, without anything, I know where to send this. But now the question arises again. The problem is I need to put it here. So I need to do what? I need to put source MAC as well as destination MAC. Source MAC is going to be my AAA. What should be my destination MAC? Interesting, right? I cannot do all F, right? Because it is going to be broadcast. Then Anjali said, see, what is this address? This is my layer 3 multicast address. She said, in IPv4, if I have layer 3 multicast address, I could have easily calculated layer 2 multicast address from it. There is a procedure. Can't I do the same thing? From layer 3 IPv6 multicast address, I can calculate layer 2 IPv6 multicast address. And suppose that address is y colon y. See the beauty of this protocol, guys. And these are the concepts people have very hard time to understand. But if you know the problem, you can see that. See, any IPv6 host who is having IPv6 address also listen at multicast address, which can be calculated from it IPv6 address, right? And this IPv6 layer 3 multicast address, we can calculate layer 2 multicast address using an algorithm. We will be talking about this algorithm, but now we know, right? And by the way, this y colon y is basically your MAC address. So this is not the IPv6. This is a 48-bit MAC address, right? So we can say it is y colon y, not y colon colon y. So we can write here y colon y. Simple, guys. Now, if this switch is multicast aware, right? Then it knows that where is multicast address y colon y. Maybe it is on 0/2 interface. It is, and it is going to send it here, not here, not here. See the beauty of protocol. And when I was creating this message, I didn't need to know because everything is right there. Because any host A, if it is having an IPv6 address, it will be listening at the multicast address, which can be, or that is L3, that is calculated from IPv6. And then from this multicast L3 IPv6 address, I can calculate L2 multicast address. As simple as that. This is creating my packet. When this packet reaches here, it is going to see destination MAC address. Okay, this is my multicast address. This host is going to open it, right? It means that it will be peeling this. Then it is going to say, okay, x colon x, this is my multicast address I'm listening. It is going to peel it. And then it will be seeing the real ARP-like message, which is who is 2001 colon colon 20. And 2000 colon colon 20 is this guy, and this guy is going to respond. By the way, this address, whatever we have written, this is my solicited not multicast address, right? And this message is my essay message. And we will be talking about this message in real detail tomorrow. I can understand this might be difficult, but if you see the topics, if you understand why I taught you that encapsulation, because I would like to explain you that in IPv6 only ICMP version 6 is the protocol which is doing your echo request, echo reply, and ARP-like messages also. And these ARP-like messages, of course, we are at layer 3. These are not broadcasted, but these are multicast. And that is why I taught you a little bit about IPv4 multicast. Guys, thank you so much, right, for being in the class. Now I am open. Please do ask any question, whatever you want. Mr. Arun, please go ahead.
Vishnu, when let's say
First of all, tell me, Mr.
TC1,
Arun, is it difficult or is it okay?
it's okay, it's okay.
Perfect. Now go ahead.
I got, yeah. So, in let's say one PC, they did ARP, discovery and, IPv6 to ARP MAC address, that listing is done. Okay, whether that PC needs to listen to the multicast address again?
No, ARP is not there in this environment, Mr. Arun.
Okay.
ARP is not
It's
at all.
not there at all.
Not at all there.
Okay.
See,
Okay, it's not at all
first
there.
thing first, we need ARP because we want to know the MAC address corresponding to an IP address, right? We are solving the same problem without ARP, right?
Okay.
By program means we have to program more in IPv6 because see, in IPv4, we just try to understand. If I have this PC, nobody is going to have, means it can't have its own IP address, right? You need to manually configure or DHCP has to give. So IPv6 guys are doing more work. They are saying there is a process known as automatic address assignment. Through that you can get it. They're also saying that if you get that IPv6 address, doesn't matter, through your automatic assignment, you have to listen on an multicast layer 3 IPv6 address, which is x colon x, which you can calculate from that address, whatever you have. Then they are saying at L2 level also, because corresponding to L3 multicast, there must be L2 multicast also, right? You can calculate that multicast y colon y here, as simple as that. And if we know that, see, by knowing the destination itself, I will be knowing that what is going to be its multicast address at what it is listening at, right? And layer 2 multicast address also. All this information is with us. Previously, we couldn't send the ARP message because we were broadcasting the ARP message because we do not know where to send it. Here, we exactly know at what multicast address we need to send it. Am I making any sense?
Yeah, I got it. I got that.
Perfect. Mr.